All right, this is problem 18. It says a bacterial population in a broth culture has been growing exponentially. Its density was 4,300 bacteria per milliliter 2 hours ago, and it's now at 5,850 bacteria per milliliter. The question is, what was the density of bacteria 4 hours and 15 minutes ago? All right, so I said it was an exponential model, so you should just know the basic equation for exponential models. I've got A times e to the RT. T is time, R is the rate of growth, A is the initial amount. Why is A the initial amount? That's easy enough. Initial means however much you're starting with, which is whenever time is 0. So if I plug in t equals 0, that gives me A times e to the R times 0. Anything to the 0 power is 1, so that gives me that the amount equals A. So that means A must be the amount that I had initially, or when t equals 0. So right away, I said that right now, this is the bacteria density. So I can say y equals 5,800 times e to the RT, because I know that's the initial amount. All right, so I need to solve for R. What's the rate of growth? Because once I know the rate of growth, I can plug in a specific time, and it will tell me what the density is. All right, let's use we've used this piece of information. Let's use the other piece of information we know. 2 hours ago must be when t equals -2. I'm assuming that I'm measuring t in hours here. You could also figure it out if you were measuring time in minutes, but you're going to get a different growth rate here because it will be different units. All right, so let's plug in what we know. We know that the density was 4,300 when t is -2. All right, I can solve this equation for R now. Let's go ahead and do it. So I've got 4,300 over 5,800. This is 1 over e to the 2r, because remember this was a negative exponent, which is the same thing as 1 over the positive version of the exponent. I'm going to go ahead and multiply by both denominators. I'll divide through by 4,300. Now I can take the natural log of both sides. When I take the natural log of this side, these cancel each other. When I take the natural log of this side, I'll get some number. So that gives me 2r equals whatever this number is. I'm just going to keep it in this form for the moment. And then you divide by 2. When I calculate what number this is, it's approximately 0.1496. All right, so that gives us our model now. I know what A is, and I know what R is. So I can say that the bacteria density is 5,800 times e to the 0.1496 times time. All right, what do I want to know? It says, what was the density 4 hours and 15 minutes ago? 4 hours and 15 minutes ago, time is -4.25, because 15 minutes is a quarter of an hour. So all I have to do now is plug that in for t, and I evaluate, and that should give me the correct solution.